Welcome to the lesson on troubleshooting CTs with the Installer app. In this lesson, you will learn how to use data displayed in the Installer app to troubleshoot CT issues in the field during the commissioning phase or by a service team after an installation. This training is intended to troubleshoot sites with a single production CT and two consumption CTs. It will not cover sites that have multiple production CTs and more than one set of consumption CTs. After completing this lesson, you will be able to explain what installed hardware is used to display data in the Installer app, assess the data in the Installer app and identify when the production CT is installed incorrectly, evaluate the data in the Installer app and identify when a consumption CT has reversed polarity. To get started with troubleshooting using the Installer app, you'll need to have a few items in place before you can begin. To troubleshoot on a site, you must first have an account in the installer portal for your company and have access to the site. You must also be Ensemble certified if the site you're going to is a site with sunlight backup or battery storage. If you're not certified, you won't be able to commission sites or redo CT commissioning. To get certified, go to the Enphase University and complete the Ensemble Storage Installation Certification. The last item required is the latest version of the Installer app installed on your device and the ability to log in to access the site you're troubleshooting. You can download the Installer app from the Google Play Store or Apple's App Store. Just search for the Enphase Installer app and look for the icon that you see here on the left. In this section, you will learn about the hardware and data relationship within the Installer app. This section will explain the hardware and data correlation so that you know exactly what's happening with the hardware by being able to assess the data it provides to the Installer app. The production CT measures current flowing through the middle of the CT sensor, and the current that is measured is coming from each of the PV circuit's L1 conductor that is passing through the middle of the CT sensor. No other conductors should be routed through the middle of the CT. Only the L1 conductors from the PV circuits. For this training, the production CT sensor will be referring to the black circular donut, and the CT wires will be referencing the secondary wires attached to the CT sensor. It's also important to remember that the CT wires for the production CT should never be cut or extended. This will void the ANSI compliance certification. When you're commissioning the system using the CTs, the Installer app will display data from each of the CTs during the Meter Wizard set configuration. Understanding the data on the screen and what piece of hardware is providing that data is key to the data and hardware relationship. In the production CT setup of the Meter Wizard, the current power production data that is displayed on the screen is coming from the production CT. The gateway is measuring the current from line 1 PV conductors that are routed through the middle of the production CT and converting the electrical current to wattage, which is then displayed. This value will never be a negative number if installed and wired correctly. The key takeaway here is that the data under the current power production is coming from the production CT. With the consumption CTs, the data being displayed is coming from the individual measurements being made for each of the consumption CTs. Like the production CT, the gateway is measuring the current flowing through the middle of each of the consumption CTs and displaying that data in the L1 and L2 boxes. The total home load is a value that's derived from adding the L1 and L2 values together. These values will never be a negative number if installed and wired correctly. Lastly, there are two versions of the consumption CTs available. Both function the same way, just different styles. The one on the bottom left is a spring clamp style, while the one on the right is the one that's been around for a while and has a hinge. The key takeaway here is that the data displayed under the total home load, L1 and L2 boxes, is coming from the consumption CTs. In this section, you'll learn how to use the data displayed in the Installer app to troubleshoot the production CT installation. Now that you know what hardware is providing the data being displayed within the Installer app, let's put that knowledge to work and troubleshoot the CTs starting with the production CT. To use this troubleshooting method, you must be on site with the gateway since the Installer app will have to be connected in AP mode. Once you're on site, start by opening the Installer app and finding the site you want to troubleshoot. Start AP mode on the gateway and connect your phone to it. Once connected, go to the meter configuration, tap on the production meter, and launch the meter wizard. If the meters were already enabled, you may have to disable them by swiping left on the meter you're working on and starting the wizard again. With the PV breakers on, start by verifying that the current power production and the L1 readings are a positive value. Remember from the previous section that you should see no negative values in either of these locations. This would tell you that there is a polarity issue with the CT sensor, CT wiring, or a phasing issue. You should also make sure that the value displayed makes sense. For example, if you've installed a 3 kilowatt system and it's a bright sunny day, you should expect to see roughly 3 kilowatts of power displayed if all of the PV L1 conductors are routed correctly through the middle of the production CT. If all values look correct, follow the instructions on the screen and tap the checkbox once the task is complete. If you see a negative value on the screen, the production CT polarity is reversed, or you have a phasing issue. Start with checking the orientation of the CT sensor and determine if that is the cause of the issue. With CT polarity, there are only two places that can be incorrect: the CT sensor, the donut, or the CT wiring at the terminals of the gateway. First, check the CT sensor. If an Enphase combiner box has been used, the production CT is in the bottom left of the box. The arrow on the CT sticker should be pointing up towards the top of the box. While you're looking at the CT sensor, make sure that the L1 conductor of each PV circuit passes through the middle of the CT. You'll also notice that the production CT has a flat side and a beveled side. The arrow on the sticker will always point towards the beveled side. This is a great tip to remember if the sticker ever comes off. The arrow points toward the beveled side. If the sensor is correct, move to the CT wiring at the gateway's terminal blocks and confirm that the wires are connected to the correct terminal blocks. The production CT's white wire will be connected to the top screw of the first terminal block, and the blue wire will be connected to the top screw of the second terminal block. If the CT wires are incorrect at the gateway's terminal blocks, you'll need to make that correction. Before you make the correction, turn off the power to the PV breakers and gateway before you remove the CT wires. The CT's blue and white wires will be energized if any current is flowing through the conductors that are routed through the middle of the production CT. If the CT wiring is correct and the CT sensor is correct, you most likely have a phasing issue, and you'll need to use your voltmeter and start testing to find the source of the phasing issue. Learn how to check your phasing by watching the CT Essentials video in the Enphase University. If a PV combiner box was custom built for the job, locate the CT sensor in the combiner box and ensure the CT arrow is pointing in the correct direction. The polarity arrow should be pointing towards the loads and away from what you want to measure, which is the output of the PV. Make sure that the L1 conductor of each PV circuit passes through the middle of the CT. If the sensor is correct, move to the CT wiring at the gateway's terminal blocks and confirm that the wires are connected to the correct terminal blocks. The white wire from the CT sensor should be connected to the top of the first terminal block, and the blue wire should be connected to the bottom of the second terminal block. Confirm that these are correct, or correct them if they aren't. Use good electrical safety and turn off the power to the gateway and PV circuits before removing the CT wires from the terminal blocks. If the CT wiring is correct and the CT sensor is correct, you most likely have a phasing issue, and you need to use your voltmeter and start testing to find the source of the phasing issue. Learn how to check your phasing by watching the CT Essentials video in the Enphase University. Once issues have been corrected, power on the gateway and PV circuits, reconnect your phone to the gateway's AP mode, and start the CT wizard again for the production CT. Confirm the polarity or phasing has been corrected and follow the instructions on the screen and proceed to the next step. Switch off the PV breakers inside the combiner box. When they're switched off, the current power production value will drop to 0. If you turn off the PV breakers and the production value does not drop to 0 watts, the residual wattage shown will tell you that the production CT sensor is still measuring current, and there may be a conductor in the CT that is not PV. Double-check that there are no other wires routed through the CT other than the L1 conductor from PV circuits. Correct any wiring issues and run the wizard again. Once the current power production value drops to 0 watts, enable the production meter and launch the Consumption CT wizard. In this section, you will learn how to use the Installer app to troubleshoot and diagnose installation errors with the Consumption CTs. Launch the meter wizard for the Consumption CTs, and make sure that you select Yes. You want to follow the wizard steps. Select the backup type for the installation and where the meter is installed within the wiring of the system. It's important to select the correct CT placement so that the gateway can calculate the true consumption values correctly. Look at your total home load and your L1 and L2 readings. The 482 watts in this image is the calculated wattage from the electrical current that is flowing through the conductors that are routed through the middle of the consumption CTs. Below that are the two individual readings from the CTs that are monitoring the L1 and L2 conductors from the utility. If either of those values are negative, there's only two places where reversed polarity can happen: at the CT sensor or where the CT wires land in the gateway's terminal blocks. The great thing about this screen is that you can quickly identify polarity issues on a specific phase because each phase line has its own consumption CT. One thing to note about this step: if you forget to turn off the PV breakers, you may see a negative value in the total home load. Be sure to turn off the PV breakers as indicated on this step. When you're checking the sensor and wiring, it's important to remember that the consumption CT sensor that is connected to the L1 utility feeder line will have its white and blue wires connected to the C1 terminal blocks in the gateway. The CT sensor around L2 of the utility feeder line will have its wires connected to the C2 terminal blocks. Refer to the schematic on the door of the IQ combiner box if one is used. Verify that the polarity arrow for the consumption CTs is pointing towards the loads and away from what you want to measure, which is the utility grid in this case. Correct the sensor polarity if it's incorrect. If the sensors are found to be installed correctly, check the CT wiring at the gateway's terminal blocks and confirm that the wires are connected to the correct terminals and that they are tightened and torqued correctly. Also verify that the L1 and L2 power wires going to the gateway are correct. This is a phasing issue. For the consumption CT around the L1 feeder line, the white and blue wires will be connected to the C1 terminal blocks, which is the fourth from the left. The white wire will be installed on the top terminal block and the blue wire on the bottom block. On the CT around the L2 feeder line, the white and blue wires will be connected to the C2 terminal blocks, which is the fifth from the left. The white wire will be installed on the top terminal block and the blue wire on the bottom terminal block. Check the gateway's power wires. Wiring these incorrectly will also show as reversed polarity. Don't forget to do your tug test to make sure the wires are secure. Using a voltmeter, confirm that the service conductor, line 1, is the same conductor that is wired to power terminal A, line 1, of the gateway. Confirm this by testing the voltage between line 1 at the main service panel and power terminal A of the gateway. The voltage should be 0 volts between these terminals and 240 volts between line 1 of the main service and line 2 of the gateway's L2 power terminal. Once the CT sensor, CT wires, and the gateway's power wires have been checked and corrected, check the readings in the Installer app again. There should be no more negative values. Okay, but what if you still see them? In some installations, the consumption CT's wires could have been extended if the distance between the gateway and the utility feeder lines was longer than the supplied CT wires. This should be noted somewhere on the installation design and should be confirmed before going to the site. Extending the CT wires isn't a difficult task, but keeping track of the colors of the CT wires through the extended cable can pose a challenge. Enphase has seen installation errors with this process that show up as reversed polarity. When extending the consumption CTs, Enphase suggests using the CL3R 4-wire security wire. This security wire has 4 conductors, and the colors of these wires are not the same colors as the CT wires. When joining the CT wires to the new wire, it's important to note the color of the wire that the white and blue CT wire connects to. In this example, the C1 CT blue wire is connected to the green wire, and the white wire is connected to the white wire. For the C2 CT, the blue wire is connected to the black wire, and the white wire is connected to the red wire. When connecting this extended wire to the gateway's terminal blocks, it's imperative that the blue and white wires from the correct CT go to the correct terminal blocks. Because of the color change, this could get confusing if it wasn't documented during the installation process. As a best practice, write down which CT wire color was connected to what color of the extended wire. A picture of the connections would also be great for posterity. Starting with the C1 wires, the white wire and blue wires are now white and green. The white wire connects to the top screw of the fourth terminal. The green wire, which is the CT's blue wire, connects to the bottom screw of the fourth terminal. For the C2 wires, the red wire is the CT's white wire and will be connected to the top screw of the fifth terminal. The black wire, which is the blue wire from the CT, will connect to the bottom screw of the fifth terminal. Correct any wiring issues and continue to the next step. Once you've corrected all issues with the CTs, you can finish commissioning. Turn on an additional load and you'll see the total home load increase. Confirm that the home load increased. Switch on the PV breakers and wait for the inverters to produce power. Watch the wattage drop as the inverters produce power. If the PV produces more than the home is consuming, the wattage will drop to 0 and the text will change from net power importing from the grid to net power exporting to grid. Once everything looks correct, enable the consumption meters. The CTs are now working correctly. Troubleshooting CTs during the commissioning process is the most efficient way for a company to operate. It saves time and money on additional truck rolls after the initial installation. The skills you learned in this training will make you more efficient in fixing any CT issues that are found in the field. Now that you've watched this video, you should be able to explain what installed hardware is used to display data in the installer app, assess the data in the installer app and identify when the production CT is installed incorrectly, and evaluate the data in the installer app and identify when a consumption CT has reversed polarity.